Hello boys and girls, welcome to another episode of FoulkesBrau. Today is Saturday, it's day 23 of lockdown. I'm not really going to go into the numbers today. Needless to say, our infection rate is climbing, and it is climbing rather quicker. It is starting to accelerate as they start doing more tests. In the news, interestingly enough, the Gauteng Liquor Association, that consists of all the shebeens and taverns that petitioned the president to let them trade, well, he's basically turned them down. So let's see now if they have the guts to go to the Constitutional Court as they threatened. Personally, I don't think it's a good move. I don't see the argument. Well, the legal argument is clear, but what I don't see is the method on which they want to trade. If they're going to trade purely on a takeaway basis, yes, that's one thing. But if you're going to entertain as a publican or a pub, that is not a good thing at this time, because I do strongly believe our lockdown will be extended to version 3. The numbers are pointing that way, the way our infections are going. I will link the spreadsheet in above, but what we've done is basically we've added a statistical analysis for a confidence interval. So we're basically looking at the standard deviation of the infection versus the mean or the average of the infection rate, and applying a little bit of a confidence interval to it of about 95%. Either way, the value that you come out with far exceeds your average infection rate per day for the last 7 days. So our average infection rate over the last 7 days exceeds the 95% confidence level, which means our infections are growing. It's not flattening, and it's growing quickly. Either way, today, I've talked enough nonsense. Today on the bench we have this Sony Sub-woofer. I'm not a sound person. This is the bass speaker that will plug into your audio visual unit, your AV unit for your surround sound system at home. I believe it's dead, but anyway, let's not waste any time. Let's get onto the bench and let's see what it's doing. Anyway, here we have our subwoofer on the desk. Here's the power cord, so let's plug it in and see what we see. Well, it didn't blow up, which is good. The LED didn't come on. Let's flick the power switch. Where is it? Nothing. Dead. Let's just turn this thing around. Just take the power out. I don't know what caps and rubbish are in there. So there's really not much to it. Let's see if we can give you the model number. It is, we'll just, there we go, model number SA-WP780 Active Sub-woofer, magnetically shielded type, AC input 230 volt, 50 to 60 hertz, 80 watts, and it's got a serial number and everything on it. We'll just zoom out. So really there's not much to this thing to take it apart, so I'm not going to do that on the camera. It's just wasting time. You've got a screw in there, in there, in there, down here, and 3 on, well, you can't see it, there's 3 on the bottom. So let me take them out and let's have a look. It looks like a hell of a big heatsink in the back there. A power switch down here. input, and obviously the gain or volume control foot. Let's see what magic Sony's actually got in here. So let me open it and we can have a look at the circuit from there. Right, here we are. We have the amplifier open. Obviously it is unplugged. There's really not much to this amplifier. Our AC mains comes in here, or down here, through our switch. It may seem that this is crossed over because you can see your neutral going in on this side and the neutral's coming in on that side. It's not actually. There's a nice big fat trace on the back that goes. They swap the traces around. You can't really see in here, but it goes through a MOV, metal oxide varistor, for suppression or transient suppression through the switch. Then comes to our board down here, through a fuse, nice big transformer, bridge rectifier, some filtering capacitors, two nice big transistors over here. Looks like some sort of push-pull configuration. Nice big heat sink up here. What's this? Some sort of relay. So there's really not much to this board. I don't see anything on the back. No. So let us start. First things first, I'm just going to set my multimeter to resistance. Oh, actually let's set it to continue. Let's measure the fuse. So the fuse is continuous. Let's measure across. Yeah, well, that makes no sense. So is our AC input 14.7 ohms. Now that does not make sense unless, let's see, sorry for bumping there. Let us see. Let us measure across the AC input of the bridge rectifier. I'm just gonna, we can leave it on resistance, you won't hear anything. No. That makes no sense. So it looks like we have a problem with the bridge rectifier, which doesn't make sense why it didn't blow the fuse. Okay, this is T1 amp. So let's just have a look at what fuse is put in here. And there's no marking on, well, none that I can see. No, it's very faded, so I can't actually see. Oh, wait. No, I only see that it's a 250 volt fuse. I don't see the rating. But the fuse itself is continuous. Let's just go back. We've taken the fuse out. Good open circuit that time. Okay. I don't smell anything that's burnt on here. But what I'm going to do is just push that clip back. The same with these. Okay, we can get this board out the way. Let's take this board out. Just a couple of screws, nothing fancy. Now the sun is coming out, nice and overcast this morning, and now the sun is gracing us with its presence. I must say it's been mostly overcast this lockdown, which is not ideal if you are a sun person, but anyway, it is what it is. A lot of heat sink compound on this. That should just come out there like that. Okay. That is our, let's just take our bridge rectifier D5 SBA20. Okay, for those of you playing at home, along at home, the capacitors Jamicon 3000, what is it, 3300 microfarad, 71 volts. This is obviously a complementary pair of transistors. Let us take this bridge rectifier out. I'm just going to desolder it, and then we can test it and have a look and see what we see. So I suspect that has gone for a loop. Right, let me do that and then we will come back. Right, so we've got the board up, we got it on the bench, and like a idiot, not paying attention, we measured a short over the AC side of the bridge rectifier. So I'll just switch my multimeter to diode, not paying attention that there is a transformer on that side. So our two inner legs, you guys see, let's just move our multimeter over. So there's no short there. Okay, one AC leg to the negative, one AC leg to the positive, no short, no problem. So our bridge rectifier is fine. If we go the other way around and we test it, that's a bit of a pain working like this. So our bridge rectifier is fine. And I thought, but why would this be blowing the fuse? Never mind that I didn't push the power plug in all the way properly, because as soon as I did that, it popped the fuse. So that means we have a short on this board. So if you remember those two big capacitors down there. What I did is I took, let's just move this out the way. I keep getting this heatsink compound on me. I just removed these two capacitors from the board. No problem there. And I took them out. And I thought, let us measure with my trusty LCR meter. I'll just move it up a bit so that you can see what I'm doing. Let's just lock the focus there. Now I don't know which one is which, so I'm just going to hook it up. We'll set the frequency to 120 Hertz. Why? Because 60 Hertz mains in the States, and obviously when we rectify it, the ripple will be 120 Hertz. So we hook it up to there, 120 Hertz. Let's just change that we want to measure capacitance. Open circuit. And let's just go to ESR. Nothing. But we've got a short on the thing. If we leave it in auto, nothing. So that capacitor is bad. I just move it there. We'll put the other one in, obviously observing the polarity. And it gives me a capacitance reading. The dissipation factor we won't worry about. At 120 Hertz it's fine, so let's just go switch it to capacitance. Quality. Okay. Right, so now we go and we'll do one more test. So this is our good capacitor that we've taken out here. I'm not going to bother explaining what we're all checking there. The important thing to note with these big electrolytics is that you want to have a low ESR. I'll just do one more test here. Let's just show you. I actually want to measure not the ESR, but I want to measure the resistance of it. And we can see it's giving me almost a dead short there on resistance. Let's take the good one. Well, what we are suspecting is the good one. That goes straight to obviously I must change the frequency. Fine, that's fine. Right, so we've got a bit more there, but again, this is not measuring what we think it's measuring. So if we take our multimeter, just put our multimeter in the shot here. I'm going to set it to measure resistance. I'm just going to put the multimeter across the two terminals. First we'll go to capacitance. So our suspected good capacitor, obviously observing the polarity. Come on, Craig, you need to touch it. Okay. And there we can see we actually get a capacitance within tolerance. Well, sort of, not really. Well, yeah, it's just on the border of the tolerance. If I stop touching the thing with my fingers and do this properly, yeah, 3000. And if we go to resistance, we can see we've got quite a high DC resistance. Now we got our bad one. We measure the same thing, we measure resistance. You can see our DC resistance on this capacitor is 0.3 ohm. So this capacitor here is what has been blowing our fuse. If we switch it to capacitance and we try and measure capacitance on it, it doesn't even read capacitance. We'll come back to our good one. That's trying to auto range. So 3000 mic. It's rated 3300. So 330. Yeah, it is in tolerance. But what I'm going to do, I don't know this Jamicon brand. I don't think it's very good. So what I will do is I will replace both of these electrolytic capacitors. And so that's, if we come back to our board, those two capacitors down there, bulk storage, filtering, whatever, have been giving us the problem. So it's important to remember, if you look at these things visually, we can't see the vent caps or explosion hatches or anything like that. They're not bulged, anything like that. Let's just come in here. Well, there's part of your problem. 85 degrees Celsius. So remember, these things get hot. 71 volt, 3300 mic. Jamicon, yeah. The problem is, these things get hot, and when you operate them near the rated temperature, they degrade very quickly, so the life cycle goes down. I was looking at capacitors yesterday for the other TV power supply that we did, that I need to buy capacitors for, and they were polypropylene film capacitors, because we're using it in the switch mode power supply, but we won't get into that here, why we're using polypropylene. But at what is important from the data sheet, and those are Panasonic capacitors that I bought, in the data sheet, at the rated temperature, the lifespan of this capacitor, well, for those Panasonics, was 1,000 hours. Now, if you do the maths, 1,000 hours of operation is not very long. So what we will do is make sure we get at least caps that are rated for 105 degrees Celsius. Well, that brings us to another episode of FoulkesBrau. Obviously, I don't have those capacitors in stock. It's not something I carry. I'm going to take a chance with RS Components, because my backlog of repairs, I now need to order spares and stuff. And I do say that, well, I did see on their website that we can't go to the trade counter, obviously, but I mean, in South Africa, they've stopped that for a long time. You can't just go to the trade counter and buy what you want. It's messy, so they're forcing you to order online. So I'm going to try and order online. Hopefully, during this lockdown, it might get delivered. I'm not sure. I'm going to take a chance. We can see how I went down the rabbit hole not thinking. Obviously, the AC side of the bridge rectifier, on that side is a transformer. So if I try and measure the diode out, because there's 4 diodes in it, it will give me a dead short. So when we disconnected the transformer, then we saw that the bridge rectifier is fine, but I didn't plug the AC in properly, the AC lead, so that's why the fuse didn't pop. So as soon as I put the AC lead in properly, the fuse went. I disconnected the transformer, measured the bridge rectifier and saw, but that is fine. And the immediate thing to suspect after that is those capacitors, because of the temperature rating. These things do operate hot. I mean, we can see the massive heatsink next to that for the push-pull transistor configuration. So the first thing to suspect then is the capacitors. When we're measuring with the LCR meter, we're measuring the AC reactance of the capacitor. So that's why you're reading a very low resistance, if you want to call it like that. So you're measuring the AC reactance, the AC impedance of the capacitor, and we know the capacitor passes AC. It blocks DC, but it passes AC. But when we're measuring with the multimeter and we measure resistance, we're measuring the DC resistance of the capacitor, and then we saw that the one is basically a dead short where the other one is blocking it. So anyway, I hope you found this video useful. I hope you enjoyed it. I'm sorry that the repairs are not more exciting, but they are what they are. I do believe the lockdown is going to be extended because we're just not... Well, yes, regardless of following the rules or not, the problem is that we are now basically where Italy and those guys were when China warned them. So I do believe the bad things are coming, but I do believe our medical guys are doing what they can to make sure that we're ready for it. I don't really want to go on about it. It's weekend and whatever. So, as always, take care, be safe, stay home during this lockdown period, and we'll catch you in the next one. Cheers.